So this is 6.5 slope point form of a linear function. So this is going to be a different way for us to see a linear outside of the slope-intercept form. This kind of tells us a different way for us to identify it, and very simply, using the slope and a point, we develop a form that looks like this. Where these guys are one point that is flipped from whatever is inside it. Okay, so what do I mean by that? Well, let's just graph it and let me show you. So this point really should be 4, 2. So let's plot that. Okay, and then this guy tells me that my slope is up 1 over 3. So up 1 over 3, up 1 over 3, and then down 1 over 3. And then I get to connect the line. Easy. Next one. My point here is -1, 2. So then down 1 over 2. And then my slope tells me to go down 1 over 2, down 1 over 2, up 1 over 2, up 1 over 2, and so on and such. So then you just connect the points like that. Okay, so it's using this guy, and your slope. And you can graph just about anything. Let's write an equation in slope point for this line. So we have 2 points on here. And the nice thing is that we can use either of them. Our slope in this case is equal to 3 over 4. And let's use this point here. So that gives us -2 and -1. So y is equal to -2, x is equal to -1. So let's plug that into our form here. Y minus -2 is equal to 3/4 x minus -1, which leaves us with y plus 2 is equal to 3/4 x plus 1, brackets. Change this to slope-intercept form. Okay. This will help us figure out what the y-intercept is. So y plus 2 is equal to 3/4 x plus 3/4. So I distributed that. Subtract 2 over 1, which changes to 4 and 8. So y is equal to 3/4 x minus 5/4. Okay. Let's do the next one here. Write an equation in slope point form for this line and change the equation to slope intercept form. So our equation, our slope in this case is -1/3. And I'm going to use this line, this dot right here, because y is equal to 0 and x is equal to 4. So that would be y minus 0 is equal to -1/3 x minus 4. So y is equal to -1/3 x minus 4. So this is technically still slope point form, but it's also really close to slope intercept form. So if I want to change this, I just distribute that in. And we can see that that is about 4/3. So that makes perfect sense. Writing an equation of a linear given 2 points. So the sum of the angles, s degrees in a polygon, is a linear function of the number of sides n of the polygon. The number of angles in a triangle is 180. The number of angles, the sum of the angles in a quadrilateral is 360. Write a linear equation. So we know that n is equal to 3, s is equal to 180. And we know that we have n is equal to 4 and s is equal to 360. So this is talking about a triangle and a quadrilateral. So then this is s minus 180, because because this is all we know. We cross multiply. Oh, this can change a little bit. This would be 360 minus 180, 4 minus 3. So then this would be s minus 180 is equal to 180 n minus 540, because I simplified this and then I cross multiplied. So that leaves us with s is equal to 180 n minus 360. I had this here just in case we wanted to graph it, but we don't necessarily have to. Use the equation to determine the sum of the angles in a dodecagon. That is a 12-sided shape. So s is equal to 180. 12 minus 360 is equal to 1800. Write an equation that is parallel or perpendicular to a given line. So write an equation that passes through r1, -1. So 1, -1, that's r. And it is parallel to the line that is 2/3 x over 5. And we want it to be parallel. So if I want to write this in slope point form, this is actually really easy because I know it needs to have a point and I know it needs to have the same slope. So if we look at this, and it's got to pass through this point, right? So it's got to pass through 1 is equal to 2/3 x minus 1. So this will create a parallel line. And if we graphed this, and let's do, so you guys can see, so 1, 2, 3, 4, 5. And then up to 1, 2, 3. Down to, okay, and then let's draw a nice straight line through it. And then I want to use this guy. Then all I have to do is go up 2 over 3. And we'll see that this line should be, that's not far enough, up 2 over 3, that's better. And then we draw a straight line. That should be parallel. That is the wrong color. Come on. Black, please. Good. Now let's draw the line. And they should be about parallel. So if I'm looking at B here, and let's do this one in blue, and I need it to be perpendicular, what do we need to do? So it needs to have a negative reciprocal slope, and it needs to pass through that point. And that's it. So then if we went down 3 over 2, down 3 over 2, up 3 over 2, up 3 over 2, and drew a nice straight line through that, that line should be pretty parallel. Okay, so that's the nice thing about using the slope point form when we want to find stuff like that.